There are 35,000 particle accelerators on the world in operation today, from cancer therapy to industrial applications like building chips, so very important for machine learning. With the PACMAN project, we aim to bring particle accelerator operation and machine learning together. Two of the world's most complicated machines are actually located in Switzerland. The LHC, which is has the world's highest energy, equivalent kinetic energy stored to an aircraft carrier, and HIPA at PSI, which has the highest beam power in the world, equivalent to an aircraft fighter. So both machines are very dangerous and require care to operate. So we aim to tackle 4 problems: minimizing the beam losses, which limit operation; better control of accelerator parameters; prevent unnecessary machine interruptions; and improve the beam dynamics modeling. For that, we have 4 different machine learning algorithms. For the minimizing the beam losses, safe Bayesian optimization, building surrogate models to enhance the performance, prognostic to detect changes in the system, and neural networks instead of physics simulations. And I want to highlight 2 of those. In the middle picture, there's LHC data from 2018. A surrogate model is built. In black is the nominal operation for these 2 parameters, and in red is the predicted optimized point from the machine surrogate model. And after that, the lifetime was measured, and we can see that the optimized point from the machine learning model is actually have a better performance. And for the lower part of the point, there is a neural network trained on a physics simulation, and it's actually performing in the same way as the physics simulation, but has a speed-up factor of 20, and this was only on a small accelerator with only 1 turn around. So if we do the same for larger accelerators, the speed-up factor will be even much larger.
Okay, thank you.
Thank you.